Hi everyone, hope you all are good. We are here for grade 9 math. So we are working on the book Principles of Mathematics grade 9. We are working on the chapter measurement, and the lessons we're going to cover today are volume of pyramids and cones and volume and surface area of a sphere. So let's just start with the lesson. Okay, here I am on the lesson. Volumes of pyramids and cones. So let's just start with the lesson. The volume of a pyramid is The volume of a pyramid is one third the volume of a prism with an identical base and height. The volume of a cone is one third the volume of a cylinder with an identical base and height. The formula for the volume of pyramid is V equals 1 by 3 times AH, where A is the area of its base and H is the height. The formula for the volume of a cone is V equals 1 by 3 pi r square h, where r is the radius of its base and h is the height, right? So let's just start with the practice questions. Let's start with question number 3. Okay. Determine the volume of sand that would fill a cone with a base radius of 6.5 centimeter and a height of 12.0 centimeter. So basically we have to calculate the area of the volume of the cone, right? So you are given the base radius 6.5 and the height you are given is 12. So let's just start with question number 3. Okay, so are given, let me just write. Base is 6.5 and base radius is 6.5 centimeter and height is 12 centimeter. Right, so we have to calculate the volume. The formula we're going to use is V equals 1 by 3 base times height, right? And you're given the base radius, that is 6.5. First of all, we have to calculate the base, that would be pi r square, right? So pi is 3.14, r is 6.5 square. Let me just do calculations. It would be 6.5 square times pi, that is 132.66, or you can say 132.7, that is the base centimeter square. You have to calculate the volume. We have now base and height is already given. Let's just substitute the value in the formula. That would be 132.7 and height is 12. Let's just multiply them and divide them. It would be 132.7 times 12 divided by 3. So it is 530.6. So the volume is 530.6 centimeter cube, right? Okay. Okay, let's just start with question number 4. Semi has a regular octagonal based pyramidal paperweight filled with colored liquid. It has a distance of 4.2 meter from the center of its base to the midpoint of each side. A base parameter of 19.0 centimeter and a height of 6.0. What is the volume of the pyramid? So basically we have to calculate the volume, right? Question number 4, you have to calculate the volume of the pyramid. That would be V equals 1 by 3 times base times height, right? Okay, so to find the area of the octagonal 8-sided polygon and its base, we will have to divide into 8 equal triangles, right? And the area of the triangle we know is A times H divided by 2, right? So the area of polygon is then, you have 8, because that is an 8-sided polygon, so it makes 8 triangles, right? It would be 8 AH times 2, so 2 times 4 is 8, so it would be 4 times AH, right? So let's just consider the base has 8 sides, right? So its parameter is 8a, p equals 8a, right? Let's just calculate the value. P parameter you are given in is, the parameter is 19, right? So it would be 19 equals 8a. So 8 equals 19 over 8, that would be 2.38. So a equals 2.38. You can calculate b from here. That is b equals 4, a is 2.38, and h is, you are given h in the question, 4.2. So that is 40 centimeter square. Now you have the value of b, just put the values in the formula. That would be 1 by 3 times base is 40 and height is 4.2, I think. No, 6 it is. So it would be 80 centimeter cube. That means the volume of the pyramid is 80 centimeter cube, right? Okay. The next one is, what is the volume of the cone? Question number 5. You are given L is 4.2 meter and radius is 1.6 meter. V equals 1 by 3 base times height, right? You are given the base radius, that is 1.6, I think. Yes, you are given the radius, that is 1.6. First of all, you have to calculate b, that would be pi r square. Pi is 3.14 and r is 1.6 square. Let me just calculate the value. That is 8.03, right? Just you have the value of b now, just put the values here. V equals 1 by 3, 8.03 times h is 4.2. So just evaluate the values, it is 11.26. So the volume is 11.26 centimeter cube, right? Okay. Okay, the next one is okay. Let's just start with question number 7. A square pyramid has a volume of 100 centimeter cube and a base area of 40 centimeter square. What is its height? So you have to calculate the height. You are given the volume and the base area. You have to calculate the height, right? The volume is 100 centimeter cube and the base area is 40 centimeter square. Okay, you have to use 1 by 3 b h. You are given the volume 100 centimeter cube and the height 40. Okay, you have to calculate the base area, right? Let's just put the values. V equals 100 centimeter cube, 1 by 3, b and h is 40, right? So it would be, let's just multiply 3 other sides, so it would be 300 centimeter cube and that equals 40b. Now let's just divide both sides by 40. Why I am writing like this, like I am falling down? Okay, 300 divided by 4 is, okay, so 400 divided by 300 divided by 40 is 7.5, right? That means the base is 7.5 centimeter square. Centimeter is not centimeter square, right? Okay, the next one is question number 9. A pyramid and a prism with the same height. A pyramid, a pyramid and a prism with the same height both have a base area of 64 centimeter square. How do their volumes compare? So they have the same height, right? Okay, the base area of 64 centimeter square. The volume of the prism is base times height, right? And the volume of the pyramid is 1 by 3 times base height, right? So you are given their base area is 64 centimeter square, right? You can see the volume of the pyramid is 1 by third time the volume of the pyramid is 1 by 3 times the volume of prism, right? That means the volume of pyramid is a third of the volume of the prism, right? Okay, the next one is okay. The next one is question number 11. Describe the volume problem solving process you would use to compare the volume of a square based pyramid and a cone with the same height. Okay, volume of square based pyramid and a cone with the same height. The volume of a pyramid with a square base is equal to the product of 1 by third of base and height, right? It would be 1 by 3 base times height. And the volume of the cone is 1 by 3 pi r square h, right? Basically, here you have the b, right? This b is exactly same pi r square. If their height is same, that means they both have exactly same value, because this is the area of the base, right? So they are, if their height is same, that means the volume of pyramid and the volume of the cone is exactly same, right? Okay, the next one is question number 12. For each right pyramid, the base is a regular polygon with a equals 4 centimeter and height equals 10 centimeter. Develop a formula to compute the volume of each pyramid in terms of a and h. Use your results to state a formula for the volume of a cone with a height of 10 centimeter and radius of a. Okay, so the volume is the amount of space occupied by a figure, right? So it would be V equals 1 by 3 base area times height. So for the first one, you can see the base is square, right? So you have to, so the base is in the shape of a square. It means the base area is the length of side squared, right? It would be S equals to A. So the volume of the square is 1 by 3 times S square times H, right? And S is 2A, so it would be 2A square times H. Let's just put up the values. It would be 1 by 3, 2 times 4 square times 10. So 2 times 4 is 8, 8 square 64, 64 times 10 is 640. It would be 640 divided by 3. So that means it is 213 centimeter cube, right? Okay, you can complete the lesson by yourself. Later today we are done with the lesson. So the questions I skipped, you have to complete them on your own. We're going to start the new lesson, that is volume and surface area of a sphere. Let's just start with the lesson. Okay. The surface area of a the surface area of a sphere is 4 times the area of the circular cross section that goes through its diameter, right? So the volume of the sphere is two-thirds the volume of a cylinder with the same radius and height. The formula for the surface area of a sphere with radius r is SA equals 4 pi r square. The formula for the volume of a sphere with radius r is V equals 4 by 3 pi r cube. The surface area of a 3D figure composed of other 3D figures is the sum of the exposed surface areas of the other figures. The volume of 3D figures composed of the other figures is the combined volume of the other figures. Let's just start with the practice questions. Okay, question number 3 is calculate the surface area of a soccer ball with a radius of 12 centimeter. Explain what you did. Okay, so you have to calculate the surface area of the ball. The radius you are given is 12 centimeter square. So let's just start with question number 3. Basically, we need to calculate the surface area of the sphere, right? That would be A equals 4 pi r square. So you are given the radius is 12. So it would be 4, 3.14 times 12 square. Let's just calculate the value. It would be 1809.55 centimeter square, right? So that means the surface area of the soccer ball is 1809.55, right? Okay, the next one is question number 5. Jim runs a company that makes ball bearings. The bearings are shipped in boxes that are then loaded onto the trucks. Each bearing has a diameter of 0.96 centimeter. Each box can hold 8,000 centimeter cube of ball bearings. How many ball bearings can a box hold? Okay, the diameter is 0.96, right? Basically, 8,000 centimeter cube is the volume of the box, right? Question number 5 it is. You have to calculate the volume. That would be 4 by 3 pi r cube. Pi r cube, right? So you are given the diameter, right? That is 0.96 centimeter. You just calculate radius. That would be d by 2. That is 0.96 divided by 2 is 0.48. So we have to then find the volume of a single ball bearing, right? It would be V equals 4 by 3 pi cot of 0.48 cube. Let's just evaluate. It is 0.47 centimeter cube, right? So now you have to find the number of ball bearings that fit in a volume 8,000, right? So you have to divide n divided by 8,000 divided by 0.47. So it would be 17,021 ball bearings can be fixed into a box, right? Okay, the next one is each ball bearing has a weight mass of 0.95 gram. Determine the mass of each box. You have to calculate the mass of the each box. Here is the ball bearings in the box. You have to do mass is 17,021 and you are given that is 0.95. Let's just multiply, it would be 16.16 kilograms. Okay, the next one is the maximum mass a truck can carry is 11,000 kilograms. What is the maximum number of boxes that can be loaded into a truck? So you have 11,000 kilograms, right? So it would be n equals 11,000 divided by 16.16, that equals 680.27. That means in a truck you can fix 680 boxes. Okay, the next one is beside the ball bearings mass, what else must be considered when loading a truck? So ball bearings can roll and must be packaged accordingly, right? Okay, the next one is okay. Let's just start with question number 7. Earth has a circumference of about 4,000 kilometer. Estimate its radius to the nearest tenth of a kilometer and use the radius to calculate the surface area to the nearest 100 square kilometers. Okay, let's start with question number 7. A. Okay, Earth has circumference of 40,000 kilometer, right? Question number. So we need to calculate the radius of a sphere from its circumference, right? Circumference is c equals 2 pi r. So you're given circumference 40,000. It would be 2 pi r. So divided by the 2, then it would be r equals 40,000 divided by 2 pi. So r equals 6,366.2 kilometer, right? Okay. So hold on, let me just check. Okay. We need to find the surface area of the sphere, so it would be A equals 4 pi r square, right? So your R is 6,336. So it would be 4 times pi, and R is 6,366.2 square. Let me just calculate the value. Okay, so it's a bit long value, that is 509,296,182 kilometer, right? That means the surface area of the earth rounded to the nearest 100 kilometer is this one, right? Okay, let's just see the B part is Mars has a surface area of about 144 kilometer square. Determine the surface area of Mars to the nearest 100 kilometer. You have to calculate the radius of the Mars, right? You are given the surface area. You have to calculate circumference. You are given the surface area, right? So basically, we have to do the inverse of this process, right? You have you are given the surface area, so it would be 144,800,000 equals 4 pi r square, right? Let's just evaluate the r from here. R square, it would be 144,800,000 divided by 4 pi. Let's just divide and calculate the square root. It would be r equals 3394.5, right? Now you can find the circumference. So C equals 2.33, 2 times 332 pi r square. R is 94, 2 pi r. C equals 2 pi r is 2, r and pi is 3.14. Let's just multiply all the values. It would be 21,328 kilometer, right? That would be the circumference. So the circumference of the Mars is 21,300 kilometers, right? Okay, let's just start with question number 10. A basketball has an a baseball has an inner core covered with string. The ball's circumference is between 23 centimeter and 23.5 centimeter. Between what values must the surface area fall? Okay, you have to calculate the surface area, right? Question number 10. Okay, you have to calculate the surface area. The circumference is 23 and 23, between 23 and 23.5. Area equals 4 pi r square. You are given the circumference, so C equals 2 point. The circumference is between 23 and 23.5, right? Let's just calculate the value for C equals 23. 23 and 2 pi r equals 23 divided by 2 pi. So r equals r1, you can say 3.66. Let's just do for 23.5, right? So 23.5 equals 2 pi r2. So r2 equals 3.74 centimeter, right? So just calculate the area for two different values of the radius, right? R1 and R2. So A1 equals 4 pi 3.66 square. Let's just evaluate. It would be 168.33, right? Let's just calculate area 2. That would be 4 times 4 pi and 3.74 square. So it is 175.77, right? So that means the area is between these two values, 168.33, and the second value is 175.77, right? Okay. The next one is question number 13. Determine the surface area of ball bearing with a volume of 6.75 centimeter cube. So you are given the volume of the ball bearing, that is 6.75. You have to calculate the surface area. Volume is 6.75 centimeter cube. V equals 4 by 3 pi r square, pi r cube, sorry. And you are given the V 6.75. So just evaluate R, right? 3 times 6.75 divided by 4 pi. So let's just evaluate the value. It would be 1.26 centimeter, right? You have to evaluate the area. So A equals 4 pi r square. You have the r, 4 times 3.14 times 1.26 square. So let's just evaluate. It would be 19.95 centimeter square, right? Okay, let's just do question number 17. A balloon is inflated to the radius of 10 centimeter. By how much will the radius increase if you add 1 liter of air to the balloon? Okay. So first of all, we're going to convert the radius into decimeter, right? R equals 1 decimeter. Then from 100 to it would be just 1 decimeter. So V equals 4 by 3 pi r cube. So it is 4 over 3, 3.14. R is 1 cube. So that would be 4.19 liter. So we then add 1 liter to the total volume, right? You have to add 1 liter to the total volume. So it would be 4.19 plus 1 equals 4 over 3 pi r cube. So it is 5.19 plus equals 4 over 3 pi r cube. Just evaluate it for the r, right? That is 3 times 5.19 divided by 4 pi equals r cube. So just evaluate. Hold on. R equals 1.11 decimeter, right? So that is the radius of the balloon, right? Okay, you can complete the rest of the questions by yourself. So please make sure before the next session you can complete all the questions I skipped. So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday, 5 to 9. So we were working on grade 9 math. Chapter we're working on is measurement, and the lessons we have covered are volume of pyramids and cones, volume and surface area of a sphere. So if you have any question, you can please ask. Okay, then that's all for today. See you in the next session. Bye, everyone.